Problem 20 states, given the following tree and access probabilities, calculate the Shannon entropy. So we see the probabilities corresponding to the specific nodes. So what we're going to do, let's first go over to the document camera and then determine what the Shannon entropy is. So recall that the Shannon entropy is the summation. So let me write out the equation here. So the Shannon entropy is equal to the summation of negative of the probability of the specific node times log of P of I. And one thing, if you have one of these old school TI-36 type calculators, good thing to know is that log base 10 of P of I divided by a log base 10 of 2 gives log of P of I. So what we want to do is we want to write out the probabilities, to calculate the entropy of each node, and then sum it to get the Shannon entropy. So we have in this tree elements 1 through 7. And we have the probabilities. So 7 and 1 both have 20%. So we're going to say 0.2 here. 2 has 10% probability. 3 has a 40% probability. 4 has a 8% probability. 5 has a 1% probability, and 6 has a 1% probability. So we have two instances where we can getting the same result, so we don't need to do it twice. So if we have, let's calculate 1 and 7 first. And so the way we do this is we do 0.2, and we do, that's log base 10 of 0.2, divided by log base 10 of 2, and that gives us negative 2.3219. Then we multiply by 0.2, because that's P of I, and then we get the negative value. And so that gives us 0.4643, 0.4643. And now we're going to do the same thing with 5 and 6 to save us some time as well. So we're going to do 0.01 log divided by 2 log base 10, and that gives us negative 6.6438. Now what we're going to do is we're going to multiply this by 0.01 and then multiply by negative 1 here, and we get 0.0064, 0.0664, 0.0664. So now we only have 3 left, so we're going to have 0.1 divided by 2 log. That's negative 3.32. We multiply that by 0.1, take away that, so that gives us 0.3321. 0.4, we're going to do the same thing, so it's 0.4 log divided by 2 log. And then we multiply times 0.4. This is going to give us 0.5287. Then we do, lastly, 0.08 log divided by 2 log. Gives us the negative number as we hoped for, times 0.08, take away negative 1, and we're going to get 0.2915. So now we just sum these values up. So it's 0.4643 plus 0.3321 plus 0.5287 plus 0.2915 plus 0.0664 plus 0.0664 plus 0.4643, and that gives us 2.2137. So now let's compare that to our multiple choices. And we see that B is our correct answer.